Alright, so I'm going to sit down and do section P3. Now that we've been through sections P1 and P2, we're going to hit a string of what I'd call easier sections. The very last section in chapter P has a little tricky thing in it, but the next 3 or 4 sections are pretty friendly. There's some terminology that we have to learn. I won't test on terminology. I'll never ask for a definition on a test, but I'll use words frequently when I lecture, and you just have to have an idea of what the word means, or at least when I say a word, if you don't know what it is, you have to be able to go back in your notes and find out what it is. And the first word that we're going to get today is a monomial. And a monomial is a real number, or we'll just say a number for this point in the semester because we don't know anything but real numbers. You might have seen imaginary numbers, and the imaginary numbers have the letter I, and we're not talking about those just yet. And if you've never seen these, it hardly matters. We'll see them in a few months, I imagine. But anyways, a monomial is a real number. It could be a fraction, could be an ugly square root, could be something like pi. So these are all examples of real numbers. Like the number 7 is a real number. The number -3/4 is a real number. Pi, which is 3.1415, and has a decimal expansion that goes on forever, is a real number. The square root of 11 is a real number. So just about any number that you can think of is going to be a real number. So a monomial consists of a real number multiplied by one or more variables. And those variables have to have whole number exponents. So very specifically, something like this would be a monomial. 3x to the first, y to the second, because it fits this. It's a real number, 3 is a real number, and then it's multiplied by 2 variables, and each of the variables has a whole number, and whole numbers are 0, 1, 2, 3, 4, basically positive integers. So that would be an example of a monomial. What we need to go through is just to look at different terms and see if classify them as monomials or not monomials. And I tried to write a little bit more. I said a monomial may contain a numerical fraction, like for instance this 2/3 z to the 7th power. This would be considered a monomial. It's okay for the real number or the coefficient to be a fraction, but it's not okay to have an exponent that's a fraction. So this is a monomial, this is a monomial, but something like this wouldn't be a monomial because its exponent isn't a whole number, its exponent is a fraction. This is a naught. Here's another naught. It's not because the exponent is a negative exponent. I also kicked a little extra wordage here that says you can't have a letter in the denominator of a fraction. So this also, something like 3/x would also be not a monomial. So we just need to go through the first 16 problems and classify them as either monomial or not monomial. And specifically, to be a monomial, you have to have a real number multiplied by one or more letters with integer exponents. Technically, you could have just a number and it could be a monomial as well. The number 4, I would consider this a monomial. It doesn't really fit with my definition so well because my definition basically says you need to have a variable, but because this equals to something that has a letter, like 4x to the 0 power, because 4x to the 0 power is 4, because x to the 0 is 1. So a number without a letter, it kind of doesn't fit my definition, but I'm going to call that a monomial as well, because it's going to be important when we get a little bit deeper into the section. So now I'm going to go through the first 16 problems, and see if each of these terms fits the rules to be a monomial, or if it doesn't fit the rules to be a monomial. So number 2, 7y to the 4th, it has a real number, has one variable, and the exponent is a positive integer, or 0, 1, 2, 3, 4. So this is going to be classified as a monomial because it meets all the criteria. Number 4, I consider it not a monomial. And the -2 exponent makes it not a monomial. Because to be a monomial, your exponent can only be 0, 1, 2, 3, 4, 5, 6, 7, 8. Any integer 0 or bigger, but negative integers don't work for monomials. 6, it almost looks like it's gonna fail my rule, but I have to understand that negative in front of the z, it really implies a -1. So this right here is actually a monomial because it really is -1 times z to the 8th. These mean the same thing, and that fits the rules perfectly. It's a real number. It could be a positive or a negative number. It could be a fraction. It could be a square root. Just as any number to the left of a letter, as long as that letter has an exponent that's a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it's going to classify as a monomial. And I'm not limited to the number of letters that I have. So when I look at problem 8, the -5 is fine. That's a real number. I look at the letter y, it has an exponent of 4. That's an okay exponent for this to be a monomial. I look at the z, I don't see an exponent. When there's no exponent written, there's an implied exponent of 1. So this classifies as a monomial because it has a real number, and every letter that it's multiplied by, or variable that it's multiplied by, has an integer exponent, or a positive whole number exponent, should I say. When I look at number 10, it's okay to have a fraction in front of the letters. That makes no difference. As long as I don't see the letter I and get an imaginary number, whatever number's listed to the left of the letters is going to be okay to classify something as a monomial. I see 3 variables, and 2 of the variables don't have exponents, which means they have implied exponents of 1, and those are all okay exponents. As long as my exponents aren't negative numbers or fractions, they're okay exponents to classify as a monomial. So I'll classify 10 as a monomial as well. The next 2 problems start to break down for different reasons. Problem 12 is considered not a monomial. The 3/2 isn't bad, the x isn't bad, but the exponent of -5 on the y makes it not a monomial. So because of the -5 exponent, because monomials are only allowed to have exponents like 0, 1, 2, and so forth. 14, if you went back to this first sheet, I added this little comment: you may not have a variable in the denominator of a fraction, which variable and letters I use interchangeably, and that's going to make 14 not a monomial. The 3y and the 4 aren't messing me up, but the x in the denominator make this not a monomial. And then the last one in this grouping, number 16, it's also not a monomial because of the y in the denominator. So they're reasonably easy to pick out whether something's a monomial or not. Hopefully not too much of this flew off the screen. So problems 17 through 28, each problem between 17 and 28 has a monomial, and when we have a monomial, we classify a monomial, or we label parts of a monomial. There's a coefficient and a degree. The coefficient is the number to the left of the letter. So in problem 18, I'm asked to determine the degree and the coefficient. The coefficient in problem 18 is the number to the left of the letter. And so the coefficient is going to be the number 9. The degree, when there's just one letter, is just the exponent itself without the letter. When there's more than one letter, the degree, you have to add up all the exponents of each of the letters. And in a second, we'll get to a problem that has more than one letter, and I'll better explain how to find the degree when there's more than one letter. For problem 20, I have to remember that if there's not a number written to the left of a letter, there's an implied 1. And the coefficient is the number that's written to the left of the letter. So I screwed that spelling up. So the coefficient in problem 20, even though it's not written, is the number 1. And the degree of that monomial is 7. In problem 22, I see the coefficient, but I don't see the exponent. The coefficient is the number 4/5. The degree is the exponent, but not including the letter. And that y, because it didn't have an exponent written, there's an implied 1 for its degree. For problem 24, this is where the first one where I have 2 letters. It doesn't mess up the coefficient. The coefficient is still the numbers written to the left of the letters. So the coefficient is going to be 2. And the degree, when you have more than one letter, you add up the exponents. So here I'm going to add up the exponent of the A and the exponent of the B. I'm going to get 11 for my degree. 26, there's a negative written next to that y. That negative is short for just a -1. So the coefficient in problem 26 is -1. And then the degree, I have to add up the exponents on both the y and the z. The y doesn't have an exponent written, but there's an implied 1, and its degree is going to be 3. 28, I have to think of it as -1, a to the second power, b to the first power, c to the first power, and its coefficient is going to be the -1. And the degree, I'm going to add up the exponents. 2 plus 1 is 3 plus 1 is 4. These problems aren't in the handout, but I'm going to consider these all monomials. And for each one of these is equal to that number times x to the 0 power. So when I have a constant or a number that doesn't have a letter, I'm going to consider that a monomial. And in this problem 28a, which is something I just made up, it's not on the handout, I'm going to say the coefficient for this 28a is 7. And I'm going to call the degree 0, because 7x to the 0 is the same as 7 times 1. We did the 0 exponent in the last section, and 7 times 1 is 7. And for this 28b that I made up, the coefficient is going to be 5, and the degree is going to be 0. And for the 28c that I made up, the coefficient is going to be -2, and the degree again is going to be 0. So we call it a constant monomial. When there isn't an x or a y, when there isn't a letter, it's considered a constant as opposed to a variable. And constant monomials all have degrees of 0s, and the number itself is considered the coefficient. All right, so new word, new definition, and the title of the chapter. If you read the title of the chapter, it was called Polynomials, and finally we're getting into the key word, I guess, in the chapter. So a polynomial is just one or more monomials being added together or subtracted together. So monomials is just a sum. A polynomial we can say it's a sum or difference of monomials. So if you look at problem 30, this is a polynomial because the first term is a monomial. 2x is considered a monomial because it fits the rule. The 2 is a nice number. The x has an exponent of 1. And the 3, we call it a monomial. We call it a constant monomial. So this would be a polynomial because it's a sum of monomials. As long as you have a string of monomials separated by pluses or minus signs, what you have is considered a polynomial. But once you put a times sign or a divide sign between monomials, then it's no longer a polynomial. So it's important that each term, this 2x is considered a term, the 3 is considered a term, as long as each of the terms is a monomial, and as long as they're only separated by either addition or subtraction signs, then you're going to have a polynomial. So this is considered a polynomial. And in problems 29 through 44, I'm supposed to first say whether this is a polynomial or not. And this is a polynomial because it's a sum of monomials. And then we're supposed to, if it's a polynomial, classify it into a subcategory. And there's 3 common subcategories of polynomials. The first one we looked at was a monomial. That's a polynomial with 1 term. Won't even have plus or minus signs. A polynomial with 2 terms, of which problem 30 is called a binomial. So I'm going to classify this as a special type of, as a polynomial. It's also a binomial because it's a polynomial with 2 terms. And the third class of polynomials is trinomials, polynomials with 3 terms. And if a polynomial doesn't have 1, 2, or 3 terms, we don't give it a special name. It's just a generic polynomial. So a polynomial is a sum of monomials, and each of the pieces separated by a plus or minus sign is called a term. And if the pieces aren't separated by pluses or minus signs, if there's times or divides, they're not polynomials. So for each problem between 29 and 44, first I'm going to figure out whether it fits the rules to be a polynomial. And then if it's a polynomial, I'll see if it fits one of the subcategories, monomial, binomial, or trinomial. When I look at problem 32, I have to look at each piece. The first term, negative 5y squared, is a monomial because it has a negative 5, which is a real number. The letter has an exponent of positive 2. That's okay to be a monomial. The second piece, 3y, that's also a monomial because it's a real number. The y has an exponent of 1. And then the 6, it's a constant monomial, so this is considered a polynomial because it has 3 monomials separated by either addition or subtraction signs. And you could have all subtractions, you could have one of each. It doesn't matter what signs separate the terms as long as only plus or minus signs separate the terms. And if I want to categorize this, because it has 3 terms, a polynomial with 3 terms is called a trinomial. So this is a polynomial, and it's also a trinomial. It's a special kind, a subcategory of polynomials called trinomials. Problem 34, because that exponent, negative 2, makes the 4x to the negative 2 not a monomial, this whole thing is going to be not a polynomial, because to be a polynomial, every single term has to be a monomial. And because 4x to the negative 2 is not a monomial, because the negative 2 exponent makes it not a monomial, can't be a polynomial. To be a polynomial, every piece, every term has to be a monomial. When I look at 36, it's also not a polynomial because this term right here is not a monomial. That term's not a monomial because of the x in the denominator. And once it's not a polynomial, I'm not going to classify it because the monomial, binomial, and trinomial only refer to polynomials. It looks like it's a binomial because it has 2 terms, but to be a binomial, you first have to be a polynomial, and it's not a polynomial because of the x squared in the denominator. 38 is also not a polynomial because of the x in the denominator. Once we have a letter in a denominator of a fraction, then what we have is not a monomial, and that can't be a polynomial then. When I look at each of the four terms in 40, 8x is a monomial because it has a real number, and then the letter has an x to the first power, which is fine. An exponent of 1 is good, so that's a monomial. The 2y is also a monomial because it's a real number 2, and the letter has a whole number exponent. The 3z is a monomial. It has an exponent of 1, and the 1 is a constant monomial. So I have 4 monomials, and they're separated by only pluses or minus signs. So that makes this a polynomial. Because to be a polynomial, you could just need a string of monomials separated by plus or minus signs. But this isn't a special subcategory. I'm not going to call it a monomial, binomial, or trinomial, because monomials only have one term. This has 4 terms. Binomials have 2. Trinomials have 3. So it's not a special type of polynomial. It doesn't get a special name. 42, that is going to be a polynomial because each of the terms is a monomial. The 4abc is considered a monomial because it has a real number, and then each of the variables, its exponents are 1, which makes that a monomial, and the -3, or the 3, is a constant monomial. So this classifies as a polynomial. It's separated by a plus sign, which is a good thing. And it's a polynomial with 2 terms, so we're going to call it a binomial. And then problem 44, because the x in the denominator, that term's not a monomial, makes the whole thing not a polynomial. So more definition type problems. So most of what I've done so far in this section has really just been definitions, and there hasn't been really any algebra, and that's going to be the case for this next bank of problems. So in problems 45 through 56, each of the problems is going to give you a polynomial, and I need to say 2 things about each polynomial. I want the degree of the polynomial, and I'm asked to identify the leading coefficient of the polynomial. In order to find the degree of the polynomial, I have to know the degree of each term, and the degree of the polynomial is the degree of the highest term. So when I look at this polynomial in 46, there's 2 terms. The first term, I'll say it's 1x cubed, has a degree of 3 because it only has 1 letter. The degree is going to be its exponent. The second term, the 5y squared, has a degree of 2 because its exponent is 2 and it only has 1 letter. The degree of the polynomial is the degree of the highest term. So there's 2 terms. One term has a degree of 3, the other has a degree of 2. The degree of the polynomial is the degree of the highest term. So that's the first thing I was asked to, well, one of the things I was asked to pick out. I missed in my instructions here. I also was asked to identify something called the leading term. The leading term is the term with the highest degree. So this polynomial has 2 terms. The x cubed is considered the leading term because it was the term with the highest degree. The term with the highest degree is kind of, it defines a polynomial. All the characteristics of a polynomial that we're going to ask for in problems 45 through 56 are all going to be based on the leading term, or the term with the highest degree. So the degree of the polynomial is the term with the highest degree. The leading term is the whole term that has the highest degree. And the last thing I wanted is the leading coefficient, and the leading coefficient is the coefficient of the leading term, or coefficient of the term with the highest degree. So the leading term is the term with the highest degree. The leading coefficient is the coefficient of this term, and that term, because it doesn't have a number in front of it, has an implied 1. So the leading coefficient is going to be 1 for this particular polynomial. That's all the definitions and everything kind of jumbled in one problem. So hopefully as I do more problems, it will start to make sense if it didn't in one problem. So I have to identify the leading term, the degree of the polynomial, and the leading coefficient for every problem between 45 and 56. And there's no algebra to do. The first thing I need to do is look at each term. The first term in this binomial is 9z, and its degree is going to be 1. It only has one letter. The exponent on the letter is its degree. The second term in this polynomial or binomial is 5x squared y, and it has two letters, so I have to add the exponents of its letters, and I tacked that exponent of y. I gave the y an exponent of 1 because I needed to know that. So that has a degree. That term has a degree of 3. So the degree of the polynomial is always the highest degree of any of the terms. So this polynomial is also going to be considered a third degree polynomial, or a third degree binomial. The leading term is the term that has that highest degree, and the leading coefficient is the coefficient of the term with the highest degree. So once I figure out the degree of the polynomial, the other pieces are just going to come, the other answers are going to come from the piece that gave me the highest degree. When I look at 50, the first term is 1y cubed. It has a degree of 3. And then the second piece, the negative y to the fourth, I'm going to consider that negative 1y to the fourth, because you could always push a 1 in front of a variable if there's no number written there. That has a degree of 4. And the last term, the positive 2y, that has a degree of 1, because when a letter doesn't have an exponent written, there's an implied 1. So for this problem, the degree of the polynomial has to be 4. The degree of the polynomial is the highest degree of any of the terms, and 4 is the highest degree. Once I know the degree of the polynomial, I'll know the leading term. It's the term that had that degree. And in this problem, you need the negative sign, but you don't need the 1. You could write negative y to the fourth, or you could write negative 1y to the fourth. They both would be okay. It's almost nicer to write it with the 1, because that helps you get the leading coefficient, because the leading coefficient is the coefficient of the term that has the highest degree. So in this problem, I'd say the leading coefficient is negative 1. Even though it wasn't a number that was written in the problem, it's still considered the leading coefficient. I just clicked autofocus, and this doesn't seem that clear today. Problem 52, it has 4 terms. It's a polynomial. The first term, 3y to the fourth, has degree 4. The second term, negative 2y to the fifth, has degree 5. The third term, 6y, has degree 1, because that y has an implied exponent of 1. And a constant, a number without a letter, we consider has degree 0, because I can think of this as negative 1 x to the 0 or negative 1 y to the 0. It wouldn't matter which letter I tacked next to the number, but if I put a 0 exponent, then negative 1 y to the 0 is the same as negative 1 times 1, which is negative 1. So a constant, a number without a letter, is considered a 0 degree term. So for this particular polynomial, the degree of the polynomial is going to be 5. Because it's the highest degree of any of the terms. The leading term is going to be the negative 2y to the 5th, because that's the term that had that degree. And then the leading coefficient is the number, the coefficient in that term, and that's going to be negative 2. 54 and 56, they're called constant polynomials because they don't have the letter, and I need to think of them for degree purposes. I can think of this as 9x to the 0. So this is a monomial, and we'll say it has degree 0. When you don't have any variables, then you can tack that variable in with a 0 exponent, and that gives you a degree 0. And the only term in this problem is the 9, so it has to be the leading term. And when I write it with a letter, you can see that it's a leading coefficient as well. So constant polynomials or constant monomials that number is the leading term and the leading coefficient, and the degree is 0. For 56, it's the same thing. Even though it's a nasty fraction, I can think of this as negative 4/5 times x to the 0. And this, again, is going to have a polynomial. It's going to have degree 0. The only term is the negative 4/5, so by default, it's the leading term. And it's the only number in the problem, so by default, it's the leading coefficient as well. So again, another just group of problems that were essentially just definition terminologies, not any algebra. So we've been through 52 problems in this section, and I haven't done a lick of algebra, which means on the test, it's going to be hard to give partial credit for those kinds of questions. So we need to just really know, based on the instructions, what you're asked to do. Because if I just looked at that problem 52 without instructions, I'd have no idea what to do with it. So the instructions are going to be super important on the test. So when I did these problems, the reason I did what I did is because I read the instructions, and the instructions specifically said find the leading term, find the degree of the polynomial, and state the leading coefficient. So the only way I would know to do what I just did is if that was asked of me. Generally, that's not ever going to be asked of you, just kind of at the beginning of an algebra class, just to get you used to some of the words that we're going to use. We'll ask those types of questions. But once we get beyond the section, I'll probably never ask you what's the leading coefficient, what's the leading term. It's probably not going to come up too often. But they're words that will be used, and it's nice to just know them. The next bit of problems is just plugging numbers into my polynomials. So I'm given you a binomial here in 58, and the instructions say evaluate using x equal to 2, y equal to negative 3, and z equal to 4. That means to go through and take out my letters, put a parentheses where the letter was, and then inside the parentheses, well, actually, and keep the numbers right when you do that. So I'm going to take out the x, put a parentheses where the x was, take out the y, put a parentheses where the y was. Now I'm going to evaluate using x equal to 2 and y equal to negative 3. I know my orders of operations well enough that I can do this pretty nicely, but if you're not good with your orders of operations, you could just do parentheses 2 exponent 3 plus 5 parentheses, well, delete, delete, delete. Notice while I was typing, everything was staying in the exponent because I forgot to get out of the exponent. So if you start typing it looks bad because the numbers aren't written in the right level, just hit the little right replay button. That will move your cursor down and allow you to type at a non-exponent. So I'm going to finish typing this. I'm using the x squared key rather than the exponent key. And that looks enough like what I have written on my paper that I'm confident my calculator is going to give me the right answer. In problems 57 through 68, the answer is just going to be a number. And it's whatever it simplifies to when I plug these numbers in and simplify. So the answer for problem 58 is going to be the number 53. If I wanted to do this by hand, you do orders of operations, you do exponent first. 2 cubed is 2 times 2 times 2, which is 8. And negative 3 squared is negative 3 times negative 3, which is positive 9. So for orders of operations, after I plug the numbers in, I do the exponents. Next step in the orders of operations here is this multiplication, which is 5 times 9. And 5 times 9 is 45. And then 8 plus 45 is going to take me to 53. It'd be nice if you did it by hand on the test, but quite honestly, it'd probably be better to use your calculator because I make less mistakes pressing buttons on my calculator than I do doing algebra in my head. So for problem 60, I wrote the problem and I deleted the z, the x squared, and the y. I left a parentheses where the z, the x, and the y were. And this problem tells me to plug 4 in for z, so I'm going to plug 4 in for z. It tells me to plug in 2 for x, and it tells me to plug negative 3 in for y. Those numbers aren't going to be constant, and I have to tell you what the numbers are. So on the test or on the practice test, I might give you instructions that say evaluate the polynomial using x, y, and z, and I might give you completely different numbers for x, y, and z, and I likely will give you completely different numbers. X, y, and z are called variables, so the numbers that I could use can vary from problem to problem. So I'm going to get an answer, then I'm going to try to do it by hand. So doing this, I'm going to go clear 9 parentheses 4 parentheses plus 5 parentheses 2, hit the x squared key, and then parentheses, negative in the parentheses here, and then 3 parentheses. The answer to this problem is supposed to be negative 24. To get there by hand, I do exponents first. That's going to make 2 squared, which is 2 times 2, the first thing I'm supposed to do in an order of operations. So that would give me 9 times 4, then 5 times 4 times negative 3. Now I'm going to do the multiplication. 9 times 4 is 36. 5 times 4 is 20, times negative 3 is negative 60. So I get 36 plus negative 60. I'm adding numbers with opposite signs, so I'm really subtracting. 36 plus negative 60 is negative 24. And notice I instinctively put a parentheses when I have 2 signs next to each other. It would have been okay and probably even preferred if I had just written 36 minus 60, because plus a negative like this is the same as a minus always. If this was a test question and if you just wrote this along with this, you'd get full credit. If you do all the work on your calculator because you're not confident in your orders of operations or you trust your calculator more than you, that's completely fine. (62), I'm going to go parentheses cubed minus parentheses 4 plus 2 times parentheses, and I'm changing the y to negative 3. Again, I can do this on my calculator and it won't mess me up. So parentheses negative 3 exponent 3, right, replay, and then minus parentheses negative in the parentheses here, 3 parentheses exponent 4, right, replay, plus 2 parentheses negative 3. And the answer to this is supposed to be negative 114. To get there by hand, I need to be able to know, do the exponents first. The first exponent is negative 3 cubed, and negative 3 cubed is negative 27. So doing this by hand, this is negative 3 times negative 3 times negative 3, which is negative 27. I'm going to bring down this minus sign, and then I'm going to do negative 3 to the fourth, which is negative 3 times negative 3 times negative 3 times negative 3. That's going to be positive 81. So when I do that, negative 3 to the fourth, you get 81. And notice I brought this minus down. The only thing that's changing on my first step is I'm getting rid of the exponents, and every other part of the problem stays the same. The minus stayed the same, the plus 2 times negative 3 stayed the same. I just did the first exponent, negative 3 cubed, turned that parentheses into a negative 27, turned the exponent negative 3 to the fourth to a positive 81. Next step is the multiplication of 2 times negative 3. So I'm going to leave the minus 27, I'm going to leave the minus 81, and I could either write plus a negative 6. If I do that, I probably should write a parentheses, or I could write a minus 6, which is kind of, for me, preferred. Now I'm still at a point where I'm going to use my calculator. When you're subtracting or adding, if all the numbers have negative signs, you just add the numbers and keep them negative. 81 plus 27 is 108, plus 6 is 114. But on my calculator, I'd go negative 27 using that negative, and then minus using that negative 81, and then minus 6. And I'd still get the minus 114. But I'm having to use my calculator. If I have to use my calculator to do any of the things, I might as well have my calculator do everything. 64, I'm going to go 3 parentheses 4 minus 2 parentheses 5 plus 6 parentheses minus 1. And each of the letters I took out with a y, and I'm supposed to plug negative 3 in for the y. So again, do it on my calculator because it's safer. So I'm going to go 3 parentheses minus 3 to the fourth, and then minus 2 parentheses, I didn't get out of the exponent, minus 2 parentheses minus 3 to the fifth, didn't get out of the exponent, plus 6 parentheses negative 3 minus 1. And my answer to this is going to be 710. By hand, first I do negative 3 to the fourth, which I just figured out was positive 81. So this would be 3 times 81 minus 2, and then I do negative 3 to the fifth, which is negative 243. So negative 3 to the fifth is negative 243. So I'd get 3 times 81, and then minus 2 times minus 243, plus 6 times minus 3 minus 1. Now I'll do the multiplication. 3 times 81 is 243. The next multiplication is a double negative. Negative 2 times negative 243 is going to be positive 486. And then 6 times negative 3, I'm going to write a minus 18. And then minus 1. And then I still don't want to do that without my calculator. So I'm going to finish this up going 243 plus 486 minus 18 minus 1, which is that string that I have there. And it best equals 710, and it does. So I did it, more or less by hand perfectly, but at this point I don't care to do that by hand. So I resorted to my calculator. And again, if you have to do any of the steps on your calculator, you might as well do the whole thing on your calculator. One thing that wasn't tricky on this problem that's going to get tricky is what I didn't do to this negative 1. I just left the negative 1 as a negative 1 because there was no letter there, which is fine. When we get to a problem that doesn't have a letter, you might get confused, and that should be coming up pretty quickly here. And what I did to the negative 1 in this problem is what I'm going to do when I get a problem that doesn't have a letter. Magically, that comes to be problems 9 and 66 and 68. So if you wanted to, you can think of this, you don't have to, but you certainly could think of this as 9x to the 0 power if you wanted to, because 9x to the 0 power is certainly equal to 9. And now I can replace the x with 2, and I'll get the right answer. So I could go, this is going to be 9 parentheses 0 power, replace the x with 2, and if I did that, I'd go 9 parentheses 2 parentheses exponent 0, and I'm going to get, for an answer, 9. It turns out that when a function doesn't have a letter, it's called a constant function, and when I'm asked to evaluate a constant function, it's always going to be that number. So 66, regardless of what values x, y, and z have, I've been told to use for x, y, and z, the answer is always going to be 9. And the safest way to deal with a constant function is just think of it, if you don't know that a constant function, a function without a letter, will always result into what that function is. I could think of it with any of the letters. So 68, I can think of this as negative 4/5 times z to the 0, and I can replace the z with 4. So I'd go negative 4/5 times 4 to the 0 power, and then that's good calculator practice here. So I'm going to go fraction negative 4 over 5, arrow out of the fraction, parentheses 4 parentheses exponent 0 power, and when I hit enter, it's going to tell me it's negative 4/5. There's no reason to do what I did in terms of putting a letter into a problem that doesn't have a letter. If you're asked to evaluate a function or a polynomial or a monomial that doesn't have a letter, then it's always, the answer is always going to be whatever that number is. It's a constant, it's called a constant function, and it doesn't vary depending on what the values of the letters are. So 66 and 68 are kind of trick questions in some sense. I'm asking you to plug numbers in for a letter, and there isn't a letter there. You can always tack on any letter to the 0 power, preferably one of the letters in the problem, and then use that number that was given for that letter. But because the 0 exponent turns into a 1, this is 9 times 1, which is 9. This 0 exponent is 1. This is negative 4/5 times 1, which is negative 4/5. This is a whole section. I didn't really feel like it was a stellar lecture. So if you're feeling not feeling really good about this section after this lecture, just tell me that it was kind of a subpar lecture, and I'll redo the video. I'm just not sure. Sometimes lecturing on stuff that's not very algebraic is harder for me to lecture on than teaching you how to do algebra, because I don't teach a lot of terminology, so sometimes the lectures are kind of clunky. So if it sucked, let me know. Like if my spelling here was horrible, that's forever wrong. I'm sure littered with spelling mistakes through this thing, but hopefully what I did is enough to get you through the section and get you through the test. And when we get to the review, because before every test there's a practice test, I'll be able to tell you specifically what you need to know and what you don't need to know from this section, and what you need to do, study to prepare and to do well in the test. Okay, that's got to be enough.